Hi everyone, welcome to Smart Semester's Python programming playlist. In this video, we are going to discuss about mutable and immutable data types in Python. A small request from my side: if you have not seen primary data types and advanced data types video before watching this video, please go through them at least once so that you will get to understand how memory will get allocated for variables in Python. If you are aware of that, then you are enough to go through this video. Mutable and immutable. The basic difference is immutable means you cannot override contents of the memory. Mutable means you can override contents of the memory. This is the basic difference between immutable and mutable. Let's see how memory contents will get overridden in case of mutable and how new objects are created in case of immutable. First, let's see immutable. Immutable data types cannot be modified after creation. Once the object is created, they cannot be modified. Any operation that appears to modify an immutable object actually creates a new object in memory, and the variable is then reassigned to new object. See, when I say a equals to 10, 10 is of int data type. In Python, int is immutable, meaning it cannot change once it is declared. It doesn't mean that I cannot store different value in a variable. I can store 20 in the same variable a. It is allowed in Python. But what happens at memory level is what it makes it as immutable and mutable. What happens at memory level is any operation that appears to modify an immutable object. Here a is an immutable object because 10 is of int data type and int is immutable, right? So a becomes immutable. Whenever an immutable object gets modified, a new object is created. Instead of overwriting 10 here itself, a new object will get created for 20 and the address of 20 will get stored in A. Let's see how this happens actually at memory level. This is the RAM where our Python program is getting executed. When we write A equals to 10, 10 is an object. For objects, memory is allocated on heap. Let's say at 1000, address 1000, 10 is stored and A is the reference. For references, memory is allocated on stack. A stores address of 10, that is 1000, and A is pointing 10. In this way, memory is allocated. Since int is immutable, meaning you cannot change. In the second line, I will write A equals to 20. Here what happens at the memory level is 10 will not get overridden with 20. Instead, a new object will be created for 20 and its address, let's say 3000. Now this 3000 will get stored in A. So now A points to the new object created and this reference will be detached. All the objects with zero reference will be collected by the garbage collector. So this memory will be freed. In this way, whenever you try to assign or you try to modify value of the immutable data types, a new object will get created and the address of new object will be assigned to the reference. Previously assigned value will get overridden and the value and the memory allocated for the previous object will be cleared by the garbage collector. In this way, immutable objects works. That is the reason I am saying any operation that appears to modify an immutable object. Here we are trying to modify immutable object. 10 is being replaced with 20. What happens when we try to modify an immutable object is a new object in memory is created, and then variable is reassigned to new object. Here a new object 20 is created and its address is assigned to the variable. The previous address will get overridden with the new object's address. This is the meaning of immutable. Mutable data types can be modified in place without creating a new object in memory. These are the examples of mutable data types: list, dict, and set. Let's see how this works at memory level. Let's say I have declared one list, list1 equals to 1 comma 2. This is the heap where objects will get created 1 comma 2. Let's say it is created at 1000, address 1000, list 1. This is the stack where references will get memory allocated. List 1 stores 1000 and points to this list. Now I will add one element to this list 1. Let's say its value is 3. What happens in the case of mutable objects is it does not entirely create a new object at the new address. Instead, it modifies here itself. A new object is not created for mutable data types. That is the primary difference between mutable and immutable. These are the different types of immutable data types. Whenever you try to assign a new value, a new object is created and the previous reference will point to the new object in the memory. These are the examples of mutable data types, meaning no new object is created for them if we try to modify them. Now, how can I know whether a new object is created or not? You can use id function. Let's say a equals to 10. Now, as we have discussed here, a, when we store a equals to 10, let's say address of 10 is 1000. If you print id of a, it will give 1000. Now, after assigning value, a new value 20 to a, try to print value of a. Now a new address will be returned which is not equals to 1000. It is not equals to the previous address because a new object is created, right? That new object will have some other different address. Now in this case, in the list case, try to print address of list 1 before and after appending the value. You will get same address, meaning no new object is created for mutable data types, only new object is created for immutable data types in Python. In this way, mutable and immutable data types exist in Python. In short, among all the data types available in Python, only list, set, and dictionary are mutable, meaning we can change their values without creation of new object, and all other data types, new objects will get created for them if we try to change their values. In the next video, we will discuss about comments and keywords in Python. If you have any doubt regarding this mutable and immutable data types, you can ask them in comment section. I will reply. Thank you.